Hello, everybody. Thank you very much for having me. Let me just quickly get set up here and share the right screen with you all. So let me just get going with that. Lovely stuff. So where are we? Excellent. So I hope everybody is enjoying the first day of Dev Day 2020. And thank you for coming to this talk. So I'm going to be talking to you about building next generation web apps with Blazor. So if I just get on the right screen, there we go. So just to say a quick reiteration about me, I'm Chris. I'm a principal software developer at Deployed. We're a female-led startup who are based in London. Microsoft MVP. I do a lot of blogging. I'm currently writing a book, and I do some open source work as well. I have various packages under the Blazor organization. So that keeps me fairly busy. But anyway, that's enough about me. Let's talk about what we're going to talk about today. So the agenda is basically a few PowerPoint slides, and then we're going to spend a lot of time in Visual Studio actually writing code and understanding what it's like to actually build a Blazor application. So we're going to start off with a quick intro to Blazor for anyone who's not familiar and is just getting started with Blazor. And then we're going to quickly move on and get into Visual Studio. I'm going to give you a quick overview of the app we're going to be working with. Then we're going to talk about forms of validation. Then we're going to move on to JavaScript interop. And then finally, we're going to finish up talking about authentication and authorization. So hopefully these topics will kind of cover all of the main areas you kind of want to deal with when you're building Blazor applications. So let's get started with the basics, and probably the best question to start with: what is Blazor? Well, Blazor is a component-based framework for building interactive UIs. Now, that's quite an all-encompassing statement, and that's deliberate. So Blazor started life as a web UI framework, and its primary kind of goal was to take on frameworks like Angular and React and Vue and things like this. But over the last year or so, we've seen Microsoft experiment more with Blazor and have a look at more opportunities to use Blazor in a wider sense. And that's down to the way Blazor's been architected. So Blazor has a separation in its architecture. It has its app or component model, which is essentially how you write the applications. It's the way you write them, the syntax, that kind of thing, the programming APIs. And that's separated from the hosting model, which is where the application actually runs. Now, in terms of hosting models, the primary ones you would have probably heard about are web-based hosting models. So this is running Blazor applications on the web in a web browser, pretty common stuff. This is the one that takes on the frameworks like Angular and Vue.js and React and things like this. But there has been some other experiments. Okay, so very early on, the team experimented with running Blazor applications on the desktop, and they did that using Electron, and later another experiment called Web Window. And that was running, like I said, running Blazor applications on the desktop, and you can access desktop APIs and all this kind of stuff. And then another really interesting experiment has been for running Blazor as a native mobile application, and that's been done using the mobile Blazor bindings experiment. Now, this one's really interesting. Excuse me. Under the hood, essentially, it's using Xamarin Forms technology, but you write all of the components, or you write your application using components, using Blazor's programming API. And I wrote a blog series on this. It's very interesting, and it's a very interesting model because as a web developer, I was able to write a mobile application very quickly. It was very intuitive, knowing Blazor from the web. So that's a really interesting one as well, and one that's gained a lot of popularity and a lot of excitement out there in the community. Now, I just want to reiterate at this point that both the desktop model and the mobile model are experimental. Okay, there's no commitment from Microsoft to develop these into products. They're not production supported, but they are being heavily looked at. And the new UI framework called Maui that's coming from Microsoft, hopefully in .NET 6 next year, has alluded to actually being able to write those types of applications using Blazor. So hopefully these experiments will evolve into the Maui framework longer term. But the one we're going to talk about today is the web-based stuff. And there's two web-based hosting models for Blazor. There's Blazor Server and Blazor WebAssembly. We're going to be working with Blazor WebAssembly today, but I'm just going to highlight the two for you and the positives and negatives of both. So Blazor Server, This is the model where your application is running on the server, that hence its name. What happens is when you load the app, a Signal R connection is established between the browser and the server, and any updates happen via that connection. So when a user clicks a button, for example, in the app, the button click event is sent over the wire, over Signal R, back to the server where it's processed, UI updates are calculated, and then those UI updates are sent back to the client browser, and then they're applied there. So everything is technically happening on the server. It's just the physical updating of the DOM that happens on the client. Now, this has got some really interesting advantages. It's got a very small payload. It's very fast to start up because you're not having to download much to the client. Blazor Server apps are pre-rendered by default, so that's useful for SEO scenarios. And again, it helps with that feeling of a fast loading application. You also get access to the full .NET runtime because your application is running on the server. So you can do everything server side that you would do with, say, a Razor Pages application or something like that. And you also get really good code security. Your code never leaves the server, okay? Everything happens on the server. It's just the UI diffs that are sent back down to the client. So you never have to worry about users getting access to your code and maybe your IP. However, the trade-offs here is that you do have to have a much heavier load on your server. So you're going to be paying that extra Azure bill potentially because you've got to have a beefier server to support those users. You also require a constant connection because all these updates happen over Signal R. Nothing really happens in the client browser. If you haven't got the server component, then nothing will work, and you get this kind of translucent overlay on the app, and the user can't interact with it. As well, because there is a lot of back and forth with the server, latency really comes into play with Blazor Server. So if you've got a connection between your client and your server that's over 200 milliseconds, then they're going to start to notice some lag in the UI. So that's a quick overview of Blazor Server. Let's talk briefly now about Blazor WebAssembly. And like I said, this is the app that we're going to be working, or the hosting model we're going to be working within our app today. Now, this one I find most people get more excited about because this one is the one that runs .NET code in the browser, okay? And it does that using this new web standard called WebAssembly. Now, specifically what happens with Blazor WebAssembly is the .NET runtime is compiled to WebAssembly, and then it, along with all of your application DLLs, get downloaded into the client browser when the app first loads up. From that point forward, your application's DLLs are actually interpreted in real time in the browser by that .NET runtime. Now, the positives here are everything's running on the client. This is great, so you can lower that server bill. Hopefully things will be a bit snappier because everything's happening on the client side. This also means that working with it offline is really easy. So working with it as a PWA is trivial. In fact, when you're creating a new Blazor WebAssembly app, you can actually make it a PWA just by checking a checkbox during the creation phase in Visual Studio. Blazor WebAssembly apps, if you use the standalone version, they're actually deployed as static files. So this means that you can actually use free hosting providers for the first time as a .NET developer. You can host your app on GitHub Pages or Netlify or Amazon S3 buckets or Azure Blob Storage, whatever you choose. And a really big benefit if you're using a .NET backend is the ability to code share. So if you're using Angular on your front end and .NET on your back end, you have to go through this process of creating DTOs in JavaScript and in C# and keeping them in sync. But with Blazor, you don't have to do that. You can put those shared classes into a .NET shared library, and you can just reference that library from both your Blazor app and your web API. So you can then make updates in one place and they're instantly reflected in both places, which is really useful. Now, as a trade-off here, unfortunately, because it is using an interpreter to do the work in the browser, it is slower for CPU intensive tasks. So in .NET 5, there was some pretty beefy improvements to performance, but generally speaking, it's still lagging behind native JavaScript performance. And there's going to be more improvements coming, hopefully in .NET 6, where we get some ahead of time compilation, and your code will actually, or parts of your code will get compiled to WebAssembly to help improve performance. There's also a larger initial download with Blazor WebAssembly because we've got to download that WebAssembly runtime and all of those DLLs. There is a bigger upfront cost. However, that is mitigated by the fact it's cached. So that .NET runtime will get downloaded the first time someone accesses your application, but as long as that doesn't change, it won't get downloaded again. It will just get cached. So That's a quick whiz through an introduction to Blazor and its hosting models and bits. It is all code from here, okay? We're going to spend the rest of the time pretty much in Visual Studio actually working on our application. So let's have a look at that application, shall we? Let me tab through here. So this is the app that we're going to be working on for the rest of this talk. This is Blazor Repairs, a fictional repairs company. And we've been tasked with adding some new features to this app. In fact, this app is pretty void of features, as it were. So we've got this dashboard page, but there isn't anything on there right now. We've got this new repair page, but there's nothing on that either. In fact, the only page that has anything on is this view repairs page, and that's talking to a web API and downloading all of the repairs that are in the system right now. So that's the app we're going to be working with. Let's go over Visual Studio and have a look at the solution. So this is the solution we're going to be working with. This is a Blazor WebAssembly ASP.NET Core hosted template, which is a mouthful, I appreciate. What this breaks down to is that we have a Blazor WebAssembly project and we have an ASP.NET Core web API that serves that Blazor front end. And then we have a shared project for sharing classes. So that's taking advantage of that code sharing I mentioned a little while ago. Now, in terms of the actual setup of the application, I've modified the template slightly. When you create a new Blazor app, you get all of your files are grouped by type. Okay, so you get a pages folder, a shared folder, data folder, that kind of thing. I'm not a big fan of that for real applications. It doesn't really scale very well. I've worked on an MVC app that had like 300 controllers, which then needed 300 views, which needed 300 view models, and it got very, very difficult to navigate. What I prefer is a feature folder approach. Okay, and that's what we're using in this application. So you can see that there's our dashboard, our new repair, and our view repair that we saw before. So inside of here, we've got components. Okay, so Blazor components all have this .razor extension. So another little tip as well when you're using feature folders, because you can end up with quite a few files in there, I like to always name the particular page. I postfix it with this page name. You never refer to these by name anywhere anyway. So I always say the pages always end with page, just to make them easier to identify in those feature folders. Other things about this app, the other thing I want to point out is I'm using Sass for styling. So I've got this styles folder here and some initial Sass stuff. So I've got a variables file. I've got my main Sass file here that imports all of my various bits, and then I have a Sass file for various parts of my application. So if we open up features and go to shared, we can go to card and we can see that, again, this kind of feature folder grouping is putting all of the related files together. So my card component here is the component file and then its style file. I'm not using any of the new CSS scoping that's in .NET 5. I'm not too sure about CSS scoping personally. I think it makes sense from a library author point of view, but in an actual application, I'm not sure. I think there's a lot of benefits of cascading CSS and scoping everything. I'm not sure where I sit on it. So I don't really use it very often personally. I much prefer this approach with Sass. Cool. So that is a quick overview of the app. What we're going to do now is actually dive straight in and start doing some work with forms and validation. And to do that, we're going to work on this new repair page that we saw earlier. So as you can see right now, there's not a lot to it. So what we're going to do is add a form here to actually be able to record a new repair. So the first thing I'm going to do is I'm going to replace this code that we've got here by default. And I'm going to paste in a chunk of code here, but most of it is this bit in the middle. And this is the bit I want us to focus on. So this is just a normal HTML form. So I've got an HTML form tag here. It's got an action, it's got a method, and then I've got labels and inputs to kind of define my form. So I'm going to just save that. And then I'm going to go back over to our app here. And if I just do a refresh, lovely. So this is the form that we've just added. OK, so this is going to allow us to put the name of the person who needs the repair, what the particular issue is, select their trade and contact number. So if we just try and go ahead and do this, and let's have a look what happens. So he's going to have we'll have a broken tap. That'll need a plumber. And we'll type in a phone number here. So if we hit save now, we actually have a problem. OK, we've hit an error. And that's because we've tried to post to an API. So first of all, we've got a type mismatch problem here. We've got an endpoint that's expecting JSON. We're posting an HTML form. Secondly, we're doing a full page post back. So this isn't great because Blazor is a single page application framework. So that doesn't really make a lot of sense either. So that's not good. So how can we actually work with forms in Blazor? Well, let's go back to Visual Studio. So the simplest thing we can do, before we can start working with a form in Blazor, we need to declare it in C#. Okay, so we need to have some kind of representation of the data model that we want to collect. So if we open up the shared project, there's actually this repair model class in here, okay, that we've already made. So that records all the same information that we've seen on that form. So what I'm going to do is, first of all, I'm going to come in here. I'm just going to add a new field to this component down here in this code block, and I can write any valid C# code I want in this code block. So in here, I've got this repair model, and this is a new instance of the repair model class, and that's what we're going to use to record the information that the user inputs. Now I've done that, I'm just going to replace what we've got here with some slightly different code. So this is actually largely the same, except what I've done is for each of the individual HTML inputs, I've used this piece of code here, this bind directive. And this is how we do two-way binding in Blazor. So what I'm saying here is bind the value of this input to this property on our model. Okay, so that's what we're doing there. So that's just two-way binding that's going on. So that's going to allow us to collect the data, but now we need to be able to process it in C# as well. So what I'm going to do is I'm going to add a method down here in the code block. Okay, this handle form submit method. Now, what this is going to do is this is going to actually take our model, and that's a little bit wrong. So let me update that. And it's going to post it off to our API, okay, using a normal HTTP client. And that is being injected at the top of our component here using the inject directive. Okay, so this is how we do dependency injection in Blazor components. So I'm injecting that, and then I'm saying, right, post my repair model off to the API, wait for the response, check that it's successful, and if it's successful, show a success message and reset my form so I can add another one. So how do we invoke this? Well, what we're going to do is we're going to replace this action and method on the form tag here, and we're going to replace that with an on submit handler. And again, this is a Blazor event here, so it has this little @ symbol at the front. So we're saying on the submit event of the form, call our handle form submit method. So let's save that. We're going to go back over to our app now and hit refresh, and that's going to reload. Now, hopefully, if all's gone well, I'm going to type in, we've got John here. He's got his broken tap. He needs a plumber. Phone number. Now, hopefully, if all's gone well, we'll hit save, and now we're seeing our success message. So this is looking good. And if we go to our view repairs page, we can see that John, his broken tap, is now in our system. So that's really good. We've actually managed to Blazorify this form, if you like, very easily by just adding a few bits of extra code. The only problem is now that if I hit save with an empty form, I still have a successfully saved form, and now I've got bad data in my system. Okay, I've got these blank entries, so that isn't very good. So let's talk now about how we can validate this form. So we'll go back over to Visual Studio. Now, the first thing we're going to do is we're going to go over to our repair model, and we're going to update this repair model. Okay, we're going to pop in some additional code. So let me do that next. So what I've done here is I've added something called data annotations to this model. Now, this is the default validation mechanism in ASP.NET. So what we've got is we've got a required attribute here, and this is making sure that our name property has a value in it. We've got a max length and a required on the issue, so we need to have a minimum length for the description. We've got a required on the trade, and then we've got this lovely, nice, easy to understand, I'm sure, regex expression here for the contact number to make sure it's a valid UK phone number because I'm here in the UK. Now, if I save that, I'm going to do nothing else at this point, okay? I'm just going to save that updated model. I'm going to do a build as well because I'm not sure if that happens automatically at this point. We're going to go back over. Now, our app's refreshed. Now, let's see what happens if we try and submit now with only updating that model. We can see here in the browser tools, we're now getting a 400 back from our API, okay? So this is now coming back with validation errors. So just by updating that shared class with those validation rules, our API has already processed those rules. It already works with data annotations out of the box, and it's already rejecting our form because it's not valid. So this is great. Step one is done. Our server is now rejecting invalid data, which is great. The problem is on our UI here, we're not really helping the user. It's not a great UX. They can't see what's wrong. They can't see what they've missed. So let's see if we can fix that next. So we're done with this repair model. So back over in our page now, what we need to do is express these validation errors somehow in our UI. Now to do that, we're going to replace this HTML form with a component that ships with Blazor, okay? So we're going to update this form to use a component called edit form. Okay, and like I said, this is a component that comes with Blazor. Now, the important part with the edit form is that it is a drop-in replacement for the normal form tag. Okay, under the hood, it's going to generate a form tag and all this kind of stuff. And a lot of what we do is going to look very familiar. So we do have to pass it a model to work with. So that's one of the things we're passing in here. And again, we're just passing in the repair model from before. Now, and instead, and one of the nice benefits of using edit form is instead of having to use that on submit handler we were using before, we get access to a couple of others, and one of them is this on valid submit. Now I really love this because I'm quite a lazy programmer, and what's really great about this particular event is that it will only call our handler for the submit if our form is valid. So it's going to pre-validate it. We're not going to have to do any validation in our own code, and we can safely code our method down here, our handle form submit method, knowing that it will only be executed if we have a valid model. So that's really, really handy and a really good advantage of the edit form. Now, along with replacing the edit form, I've updated the controls as well. So we're no longer using HTML inputs, we're now using components. And again, each of them is a drop-in replacement for their HTML equivalent. So we have an input text, an input text area, an input select, and these are all down here. And again, these are all still bound to the model using the bind directive like before, okay? So it's a slightly different syntax I will point out at this point. This is because we're now dealing with a component, so that's the reason for that slight syntactic change. We're saying bind to the value property on the component and bind that to the name model, the name property on the model, okay? So that's what that is, but it's still two-way binding going on here. So that's a big improvement. So the only other thing we need to do now is actually tell the form, the edit form component, what particular validation rules we want it to use, because Blazor actually will work with lots and lots of different validation mechanisms. Okay, it's very plug and play like that. So I'm going to add another couple of components here. The first one is the data annotations validator. Now this is what tells the edit form how to validate the form. In this case, it says use data annotations. But if you want to use something else like fluent validations, for example, it's as easy as swapping this component out for another one that does fluent validations. In fact, one of my Blazor libraries is called Blazor Fluent Validations, and it does exactly that. You can install that package, and then you just swap data annotations validator for a fluent validations validator, and that is it. Your form is now using fluent validations instead. The other component I added is this validation summary, and that's just going to show the validation errors on the UI. So I'm going to save that, jump back over to our app. You can see it's actually auto refreshing. That's a new feature in .NET 5. So now I've done that, if I hit save, we're now getting validation errors, okay? Now, this is the validation component, the summary component at the top here, that's showing all of the errors on our form. And then by using Blazor's form components, we're now getting some extra help. So we're getting this ability to style the form with errors. So I've added some CSS here to do this. And if I inspect this input, I can show you how that's done. So when we're using those built-in components, we get these CSS classes applied based on how the validity of the form. So this particular control is invalid, so we're getting this invalid class applied. If I type in a valid value and hit tab, you can now see it's changed to modified, and it's now got a valid class on it. So I've now got some styling to make it go green. So that's another nice little touch with using the built-in form components. So now I can say that broken. So John's got his broken tap again. He needs a plumber. And this time I now have to type in a valid phone number. If I don't, it will say that it's invalid. Okay, and I can correct that. And it goes, still not valid. There we go. And now it goes valid and I can now submit my form. So that's great. And I've now got valid data in my system. Everything's hunky-dory. The only thing I'm not a fan of here is I don't really like this validation summary. I don't like all the errors being away from where they are in the actual form. So the last thing we're going to do is we're going to remove the validation summary and we're just going to update these various controls to use an extra component, okay? And we're going to use this validation message component. And this allows us to show validation messages for each individual property wherever we want in the form. So I'm going to do that, hit save, tab back over. That's going to auto refresh for us. And now when I hit save, we're getting validation messages directly under the particular controls therefore. And I think this is a much nicer UX. So just as before now, I can go through, I can put in John, he's got his broken tap. He needs a plumber and he's going to type in his valid phone number and that is all going to work. And I can hit save now. It's saved successfully and John and his repair are now in the system as expected. So that's really great. So just to recap, we've moved there from using a traditional HTML form. We've modified it slightly to work with Blazor, and then we've upgraded it to the edit form component. We've added in validation and all of that good stuff and created a much nicer, richer UI experience in doing so. So that is Blazor forms and validation in a nutshell. So next we're going to be talking about JavaScript interop. So quickly, first, why do we want to talk about this? Because surely Blazor is all about not using JavaScript. Well, yes and no. Ultimately, JavaScript is not going anywhere. All right, and there's lots of really great libraries in JavaScript, and you know sometimes it's more efficient to take advantage of what's there than try and write something new. So one of the things I'm going to show, or the thing I'm going to show you today, is working with charts. And there's loads of great JavaScript chart libraries already out there. It will take a while for the .NET ecosystem to catch up with equivalents. So right now, I think it makes a lot of sense to do that. And what I'm going to show you is how you can wrap these JavaScript libraries in a C# API so that you don't actually have to work with them directly. You can create that C# wrapper and then you can just treat them like C# code from that point forward. So in order to do this, we're actually going to start off with a new file. So we're going to go in the www root folder, and in this JS folder, I've got a file here called chartmin.js. Okay, so this is a chart.js library, very popular library for doing charts in JavaScript. And what we're going to do is wrap that and work with it in Blazor. So I'm going to add a new file here. I'm going to do a new item. I'm going to scroll down. I'm going to say JavaScript file. I'm going to call this chart wrapper.js. Okay. And inside of that, I'm going to add some code. Now, I'm going to compress a load of this because a lot of it is irrelevant. In fact, all of this code I've just entered in here is most of it, at least, is boilerplate code from Chart.js's getting started guide. The bits that we want to concentrate are the first bits here. So first of all, what I'm doing is I'm creating an object on the window, so the global scope, called Blazor repairs. And in there, I've created a single function called build chart. And that build chart function takes an element, and we need to give it an element because that's what Chart.js needs in order to know where to render the particular chart. And then after that, all of this code is, like I say, boilerplate from their getting started guide. So we have the type of the chart we want to create, which is a bar chart. And then we have some labels and some fake data all here in this data sets object down here. So we're not going to worry about any of that. This is just to get us going for now with some hard-coded data. Cool. So that is our chart JS wrapper. So what we're going to do now is go to the index.html and we're going to add reference to those scripts. So we're going to reference our chart JS minified file, and we're going to reference that chart wrapper JS file that we just created. So we've done that. They're in there as well now. And then the next step is we're going to create a component to work with. So in the dashboard, because this is where we're going to use this, we're going to add a new Razor component. So this is how you do components in Blazor. They're called Razor components, funnily enough, because they use Razor syntax to write them. And we're going to call this chart.razor. So inside of here, I'm going to pop in some code and we're going to walk through it. So first of all, in this markup, I've created a HTML canvas element. So this is regular HTML canvas element. But what I've done is I've used this ref directive from Blazor to capture a reference to that element. And I can do that by creating a field with this special type called element reference, okay? And that's going to allow us to capture this reference to this HTML element and actually pass it into JavaScript from C#. Now, inside of the code block, I'm using this on after render async method. Now, this is one of 3 lifecycle methods that Blazor components have. We're going to see some more in a little bit, but this one is specifically used for JavaScript interop. Okay, it's called on after render because it fires after the component physically gets rendered to the DOM. And that's important because when we're doing JavaScript, we want that component to be physically present in the DOM so we can manipulate it. Inside of there, we're using another service called IJS runtime that we're injecting at the top. And this is our gateway into the JavaScript world from C#. We can call into JavaScript functions here. And we do that using one of 2 methods, this invoke void async and invoke async. Now, invoke async, we call that when we want to get a response back from JavaScript. But in this case, we don't. We just want to execute a JavaScript function. So we call this invoke void. So we're not expecting a return here. The first argument is the function that we want to call in relation to the global scope. So this is where that object we created in the chart wrapper comes into play. It's that Blazor repairs object and then the build chart function. So you can see here, Blazor repairs build chart. Okay, so that's where that comes from. After that, everything after that is just the arguments that we want to pass into that function. And we just want to pass down that element reference. So we're doing that there, passing down chart container, okay, which is our element ref. So we've done that. If we save that and we go over to our dashboard page, and what we're going to do is update this to use our chart component like so. So we're going to save that and then we're going to jump back over to our app, and that's rebuilt and refreshed for us. And if we go here, voila, we have rendered a JavaScript chart component. Okay, so we can see here, this is that hard-coded data we had, and that's being displayed here. And we get this nice tooltip hanging over the top and everything. So that's great. So this has worked, and we quite quickly here have been able to wrap this JavaScript library. But it's not very useful to us right now. It's hard-coded data. We need to be able to customize this, create different chart types, render different data. So let's move back to Visual Studio, and let's have a look at how we can do that. So we're going to go back over here. And we're going to go back into our build chart function, and we're going to update it. So what we're going to do is we're going to pop in some code. And what we've done here is we've removed all that hard-coded data. So instead of type being hard-coded to a bar chart like it was before, it's now a variable, and the same with that data set as well. That's now a variable. And you can see what we're doing is we're now passing these into the function like we were with the element originally. Okay, so we're passing in the type and the data. Now we've done that, we've genuinely made this code boilerplate. There's nothing really here of any consequence. It's just initialization code for creating a chart. And now that's done, we can actually close this because we don't need to use it anymore. Same with those other files as well. We can actually start working now pretty much entirely in C#. Now, because we've removed that hard-coded data, we do need a way of representing that data structure in C#. So that's what we're going to do next. So in our dashboard file here, we're going to create a new class. And inside of that, we're going to call this chart data. So I'm just going to pop in some code with this, pop that in there. Excellent. So again, you don't really need to worry about the specifics of this, but what you just need to understand about this particular piece of code now is that this is the C# representation of the hard-coded data from the JavaScript library. So we have 2 top-level items there in the chart data, which was the labels, list of labels, and a list of data sets. And here we've got a class representing what is in a data set. So again, that's now done. We don't really kind of need to worry about this either. We can close that off now. So what we need to do now is just update our chart component to take advantage of this customization that we built into our wrapper. So what we're going to do is we're going to paste in what's called parameters, and this is a way of defining the public API for a component. So all they are is public properties that have this parameter attribute on them. So what we're saying here is when someone uses our chart component, they can pass in the data they want it to display, and the type of the chart they want to render. Okay, so they're going to be able to pass that in, and we'll see that happen in a second. And what we're going to do is now update our call to our JavaScript function. And all we're going to do there is we're going to now pass the type of the chart we wanted and the data down along with the element ref that we were doing before. Okay, so now we've done that, we've made this chart component essentially everything we want to customize we can now do from C#. So the last bit really is to update how we use this in a consuming component, so in the dashboard page. So I'm going to update this dashboard page with some code. Now, paste in a fair few bits of code, but we'll break all this down. So first of all, here is we're now passing in the data and the type of the chart that we want to be rendered now, rather than just rendering the chart component. Okay, so we're adding that customizability in. Inside of the code block here, we're using one of those other Blazor lifecycle methods I mentioned, the onInitialized lifecycle method. Now, this only runs once when a component is first spun up. So it's a great place to do initialization work, hence the name. And in this case, what we're doing is we're getting the data from our API using the HTTP client like we saw before. So we're injecting that up here. And what we're doing is we're taking that data and passing it to this private method called create chart data. And the only job that method does is to return a formatted chart data object using that chart data class we created a second ago. And all we're going to do with that is pass that down into our component up there. So we've done all of that. If everything's good, we're going to go back to our dashboard and hopefully, voila, we are now seeing real data from our app. So we have now got our completed repairs in one bar here, and we've got our outstanding compares there. So we've got 3 and 5, and if we go to our view repairs page, we can see down the side we've got 3 that aren't complete and 5 that are. So that all looks that it's working really well. So we've wrapped all this stuff now in C#. We don't have to now care that we're working with JavaScript under the hood. In fact, if I go back over here and I now want to render a pie chart instead, for example, I can just update this in my C# code, go back over to my app, that's going to refresh, and now I've got a nice pie chart representing my outstanding and completed repairs, which is really, really cool. So as you can see, working with JavaScript in Blazor is actually a relatively pleasant experience. They've got nice APIs to work with, and with a bit of thought up front, you can wrap those libraries with C# APIs, and you can just work with C# for the majority of the time. Okay, it's just that initial bit of work to get going that you need to work with JavaScript on. Also, we're doing really well. We've got through a couple of sections now. We've done forms and validation. We've done JavaScript interop. So the last thing we're going to tackle is authorization authentication of our app. So in order to do that, we're actually going to start off in the server application, because the most important thing to understand when you're doing securing SPA applications is that anything on the SPA, it gets downloaded to the client. It can't be trusted. Okay, so you have to secure from the server first. So in order to do that, we're going to go into our controller. We're going to open our repairs controller here. And what we're going to do is we're just going to add the authorize attribute. Ooh, we'll do that. Add this authorize attribute to our controller. Now, this is all built into .NET. And what we're saying here is in order to access any of the endpoints on this controller, you must be an authorized user. So what does an authorized user mean in the context of this particular app? Well, in this particular app, what I've done is I've set up JSON Web Token authentication. Now, this is a bit of a custom setup. This is not something I would recommend you do. This is more for demo purposes. Normally, you would be using something like Azure AD or Azure AD B2C or Auth0 or some other identity server implementation that you're using, OIDC, OAuth, that kind of thing. But what I'm doing here is I'm essentially saying someone has to have a valid JSON Web Token in order to access this application. And I've got sort of authentication authorization configured here in my middleware. So that's what that's doing. And I've got this login controller here, and that's responsible for checking that someone who logs in are who they say they are. And I'm doing that using hard-coded username and password. So this is really, really bad. Don't do this in production, but it just demonstrates what's going on. And then it creates a JSON Web Token when a user signs in correctly. So that's what's going on under the hood. So now with that authorize attribute on our app, if we go back over to our app now, if we start clicking through, you can see that we're no longer showing repairs. our dashboard is no longer showing an API, and that's because we're now getting errors back because we're unauthorized, okay, when we try to access that data. So job one for us is done. We've secured our API and we've made that protected. That's the important bit. So let's talk about improving the user experience in our Blazor app, because that's what we're doing with the Spartan authorization. We're just improving the user experience for people who are adhering to the rules. So we're going to go into our Blazor app, and what we're going to do to start off with is we're actually going to add that same attribute that we just saw, that authorize attribute, to each of our pages, because we're going to work in the same way. So we're saying to access the dashboard page, you must be authorized. Okay, we're going to do the same with the new repairs page. We're going to say you must be authorized to access this one as well. And finally, we're going to do the same with the view repair page. Again, we're saying you must be authorized in order to access this page as well. Now we've done that, but unfortunately that isn't going to do anything for us, because with Blazor we need to tell it how someone is authorized, okay, in a similar way that we did in the API. So what does authorized mean for our application? Well, in order to do that, we need to add in something called a authentication state provider. Okay, so we're going to do that first, and I'm going to add in a new folder. I'm just going to call this providers, like so. And inside there, I'm going to add a new class. And I'm going to call this class token authentication state provider, like so. And what I'm going to do is I'm going to paste in some code here. Now, there's a lot going on in this, and we're going to break this down like we have been with the rest of it. Now, first of all, when you're creating your own state provider, most of the time you won't have to do this, okay? So that's probably the first thing I should be clear out. I'm showing you kind of the nuts and bolts of what's going under the hood, but there's a lot of state providers that are already provided by the Blazor team. So if you're working with Azure, you're working with B2C, stuff like that, there's already stuff built in there for you to do all of this stuff. In fact, any OIDC stuff is basically built in, but I'm going to show you this anyway. So under the hood, this is what goes on. You have to inherit from the authentication state provider base class. And with that, you have to override the get authentication state async method. Now, what happens is all of the components in Blazor that deal with authorization, they all have the authentication state provider injected into them. And they all then call this get authentication state method. And this is essentially returning back a true or false as to whether you're authenticated or not. Now, for our app, the way we're going to do this is we're going to do a couple of checks. We're going to start off by checking to see if there is a token in local storage. Now, how would a token get there? Well, that's where this login method that's down below comes into play. When someone logs in our app, and we're going to do that in a minute, we're basically going to save a token that JSON web token that comes back from the web API in local storage to know that they're authenticated. And that's what we're doing here. We're just saving that token into local storage. And to do that, we're using a library. It's one of my Blazor libraries called Blazor Local Storage up here. And that just saves a token into local storage. Now, when we're checking if they're authenticated, the first thing we do is try to get that token out of local storage. If we get that token out and there's something there, then we're going to parse the claims within it, and we're going to create a claims identity for that user. Now, if there isn't a token there, what's going to happen is we're going to end an empty claims identity. Okay, excuse me. Now, if that's the case, what will happen is we'll drop through all this code and we'll return an empty claims principal. And that essentially is like saying we're not authorized, we're not logged in, we're not a valid user. So that's what that's going to do. If we do have a claims identity, what we also need to do at that point is we need to attach our JSON web token to any HTTP calls we make. So we're going to update our HTTP client here to include a bearer header with the token. Okay. So that's the other thing that's going on here if we have a token. So like I say, that might sound a bit complex, but essentially just think of it this way. Components will call get authentication state async. It will return, are they authenticated or are they not authenticated? That's essentially what's going on in this class. So now we've done that, what we need to do is actually set this up in dependency injection. So we're going to come into our program CS file, because in Blazor WebAssembly, we don't have a startup file, we just have program CS. And inside of there, then I'm going to click this add services, we're going to add the services into this class. So let me just quickly format those. Now you can see I'm missing some using statements here, so I'm just going to pop those in as well. Cool. So they're all in there like so. Now what I'm going to just quickly highlight a few here. What I'm doing is I'm setting up some infrastructure for authorization. That's kind of all boilerplate stuff. I'm adding in the stuff that's needed to make my local storage library work. But what the important bit is these last two lines. So first of all, I'm adding that token authentication state provider we just created into dependency injection. So that's what I'm doing here. And then what I'm saying is any component that requests an instance of authentication state provider, don't give it the standard one. Give it R1, the token authentication state provider we've just created, so that it will use our version of the get authentication state async method. Okay, so that's all the Blazor components now will get our provider instead. So that's the dependency injection setup. The final bits that we're going to work through here now is in the app.razor. So this is the entry point into our Blazor application. Now in here we've got the router. The problem is the router by default doesn't understand authentication. It doesn't know not to navigate to a page that's decorated with that authorized attribute if we're not authenticated. So we have to tell it how to do that. So in order to do that, what we're going to do is we're going to update this root view here, which is what normally renders a page. We're going to update it to use this authorized root view instead. Now, the authorized root view does exactly the same as the standard one does, except it understands that authorized attribute. OK, so it's going to get an instance of our token authentication state provider, check that we're allowed to go to the page that we're trying to load. And if we're not, then we're going to get this not authorized template load. And in there, what we're saying is show the login screen. OK, and the login screen is something we haven't looked at yet. So inside of this login feature folder, we've got this login component, which I've had commented out up till now. So I'll comment that back in. And that has just got a simple form on it using an edit form again, and it collects the username, the password, and then down here we've got a handle submit method, and that just posts it to our login controller that we saw earlier and returns back a true or false as to whether the user is logged in or not. So with all of those bits in place, hopefully if I go back over to our app, you can see it's already refreshed and we're already seeing that login page. Okay, so if I try to go to any page in my app, I'm just seeing the login screen because I'm a non-authorized user. So if I type in my username, which is user, and it's something really secret like user1 exclamation mark as my password, you can see I'm now logged in. I'm now successfully retrieving data from the API. You can see I've got my chart rendering here. My new repair page loads up as expected, and my view repair page is again returning my data from the API. So everything's looking pretty good right now. We're authenticating correctly. We've got our token. We're making calls. Everything's working as expected. But we do have a slight problem. What happens if we don't want everybody who logs into our app to be able to view the repair data? We've got phone numbers, for example, so that's sensitive to things like GDPR. Perhaps not everyone in an organization should be allowed to see this information. So we want to scope stuff down by role. How can we do that now? Well, what we could do is we can introduce, like I say, the concept of roles. So Blazor can do that for us. So what we're going to do is go into our view repair page like so. I'm going to update this card component with some additional code. So what I'm using here is this other component called authorized view. Now, authorized view allows us to take chunks of our UI and conditionally render it based on some authentication rules. So in this case, what I'm saying is only show the content in the authorized template, which is this section of it here, if the user is authenticated and they're in the role of planner. Okay. If they're not in the role of planner, they'll be classed as unauthorized, even if they're logged in. And we're going to show them this card instead, which is this not authorized message. Inside of the authorized view, it's just the same template as before, printing out the issues in our system. So if I save that and I go back over to my view repair page, it's going to refresh. Now, remember, I'm logged in as a user currently, and you can see that I'm now seeing this not authorized view as I was before, but I can still access everything as I was earlier. So that's great. this is brilliant. This is now working. I'm in the wrong role, so I can't see this. But I also can't log out. You can see there's no way for me to log out of this application and change over to a planner role. Okay, so let's tackle that as the next piece. So in order to do that, I'm going to go into my shared folder. I'm going to go to layout, and into the header bar, I'm going to put in a new component that's going to deal with that for us. So I'm going to go add, raise a component, and I'm going to call this one user status, like so. And I'm going to pop in some code there. Now, what I'm going to do here, or what I've done here, sorry, is inject that token authentication state provider that we built a little while ago. And then I'm using the authorized view component again, but I'm using it in a more simplistic way this time. I'm not saying that someone has to be in a certain role. I'm just saying they have to be logged in. Okay, they have to be authenticated in some way, but they don't need to be in any particular role. And if they are, I'm going to show them this HTML. Okay, if they're not logged in, they're just not going to see anything at all. Okay, so I don't need those authorized and not authorized templates. When I'm inside the authorized view, I can actually access some additional information about the logged in user. I can do that via this context object that's provided by the authorized view. So I can access that by saying @context dot, and then I can get to user identity.name to print out the name of the user who's logged in. What I'm also doing here is I've got a button and it's got an on-click handler, and that's just going to call a logout method on that token authentication state provider. So we go back over there. We saw the login method before. Now we've got the logout method, okay? And that's just going to remove that token from local storage, okay? So that's what that button does now. So if I save that, and the final thing I need to do is actually add it to our header bar here. So I'm going to come in and do that. I'm going to say user status like so, and save that. And we go back to our app, and we'll catch that reloading. And you can see at the top here, it's now showing my information. It's saying hi user because I'm logged in as a user. And I've now got that nice log out button. So I can now click log out and it puts me back to the login screen. You can see everything is not working as it was before. And now I can log in as a planner as I did. And this time, if I log in, you can now see I'm a planner. So I can now view that repairs because as a planner, I'm in the planner role, but I can still access everything else like I did before. So everything's working as expected. So that's really, really useful. And hopefully the other thing I want to point out here as well is that in my view repair page, Blazor does also support policies. So if you'd rather use a policy instead, you can use that. I'm just using roles for now because I think most people are still using roles instead of policies rather than the policies, which are the newer things. So with that, that is basically everything I wanted to talk to you about today. So I'm just going to jump back to PowerPoint for the last bit. So I just want to give you a few resources that I think are really useful if you're getting into Blazor. So first of all, there's the official Blazor site at blazor.net. That's obviously really your first point of call and is a good hub to go off to other places. It's got loads and loads of great information and a portal into the MS-DOC site for Blazor as well. Secondly, you've got the awesome Blazor repo. So this is a community run repository by a guy called Adrian Torres. Adrian does a phenomenal amount of work on this repo, and it's very well curated. He's categorized everything, and he keeps it really up to date. There's new items going into that every single week, and it really is an absolute treasure trove. Content. There's everything, almost everything that's ever been done on Blazor is there. Talks, blog posts, articles, demos, apps, anything that's been done with Blazor is pretty much there. It's really, really impressive. Next, there's the Blazor Gitter chat. There's always people active in there. Very, very vibrant community, very passionate, lots of knowledgeable people in there. So if you want some real-time help, you can drop in there and ask your questions and you'll almost always get a response there. The .NET team, the Blazor team actually drop in there every now and then, especially during the Thursday Blazor sprint days. That's definitely somewhere worth being. Blazor University is another really great site by a community member, a guy called Peter Morris. Peter does phenomenal work on Blazor University. It's very much a reference style site for Blazor, walks you through all of the various features with some really great examples. Peter's put a lot of time into that and it's definitely a really great resource to check out. And then finally, another plug is my blog. I think I've got upwards of 60 articles on Blazor now. I used to publish every week, and so I started writing the book, and I've dropped off quite significantly on that. But I try to publish whenever I can, and as soon as the book's done, I'll be back to weekly blog posts on Blazor. So yeah, and obviously a shameless plug again for my book. So that is Meep. That is in Meep now, which is the Manning Early Access program. So you can start getting chapters as I write that, and hopefully that book would be really useful for you if you're getting into Blazor as well. So I think that is about it from me. I think we've probably got time for some questions and bits and bob now. So yeah, hopefully there'll be some questions available from people. Otherwise, thank you very much for listening.
Actually, Chris, we've got quite a few questions.
Excellent.
Okay, so one person is asking, how do you add custom CSS, for an example, to a validation message element?
Yeah, that's fine. I'll jump actually into Visual Studio and I'll show you. So what you can do is I've got this, I think, where did I code this? That is in my, where did I put this? Going blank now. Here we go. So inside of my base SAS file here, I've got my all my stuff for validating my form and doing my UI for the form. But down here is where the actual work happens. So what I'm saying is, for any input text area or select element, if it's got an invalid class, then I'm setting the border to red. If it's got a valid class, then I'm setting the border to green. So it really is quite simple in order to do this. The extra sort of squiggles and bits, that's SAS syntax for how that works. But that's all you have to do. Just target any of those controls and then the specific class, and then you can add your styles.
So another person is asking, where the media files be placed?
Media files? Was that, sorry?
So that's how the question reads. If it's not clear enough, shall I skip on to the next one?
Yeah, maybe next one. I'm not sure about that one, sorry.
Okay. So is it possible to develop Blazor application with on-premise MS SQL Server and Oracle databases? Also, is it possible to use Oracle DB API?
Yeah, I mean, I'll be honest, I've never worked with the Oracle DB API or Oracle DBs, but certainly, yes, you can use it with SQL Server. I mean, the important thing to understand with Blazor WebAssembly specifically is it is a browser-based application, so you can't make SQL calls directly from a Blazor WebAssembly app. Okay, you can't do that. You can do it from a Blazor Server app though, because that is running on the server, and there it's just the same as you do with anything else with C# and using SQL Server. So you could use any framework and you could make direct calls out. I would really push you to not do that from components, because it really is blurring the lines between UI and back-end code really. But yeah, it's definitely possible. And yeah, there's plenty of blog posts out there. Jeremy Lickness from Microsoft has got loads of blog posts about using Entity Framework with Blazor.
Okay, the next question is, what about exporting this dashboard data into PDF and Excel files?
Yeah, so that's pretty trivial as well. So there's plenty of NuGet packages out there that do this, and you can just install them into your Blazor app, and then you can just do what you would normally do in C# code to export them. Dan Roth did a demo. Dan Roth is the program manager for the Blazor team. He did a demo a while ago where he actually did that. He actually took some tabular data that was in one of his components, and he installed a NuGet package and hooked it up to a button click. And when he clicked the button, it exported it as an Excel spreadsheet. So yeah, it's all pretty trivial. It largely just works as you'd expect. You just hook up the UI to the particular methods and off it goes. Okay,
so next one, how hard it is to migrate an Angular app to Blazor?
Oh, that's a fun question. Well, that really does depend on what the skill sets are in your team and how big your apps are. So at the end of the day, when you say migrate, it's tricky. You're not going to be able really to mix Blazor and Angular at the same time, because both of them need to control the DOM. So the only way you can really do this is to have the app running. Well, there's different ways you can do this, but one way to do it is to have two apps running at the same time. So you'd have your Angular app running, legacy Angular app, and then you would build anything new into Blazor, and then you'd have to kind of redirect between two apps. That has some issues around it in that you kind of have to make sure that state is maintained between the two apps. So you have to have a way of doing that. So there is some complexity there. And you obviously are also dealing with the fact the user is jumping between two applications. So there can be some, reloads in the UI and things like this. So that can be a bit tricky, but that is one way of doing it. Another way is basically to develop your Blazor app, stop developing your Angular app and then develop the features into Blazor. And when your Blazor app is on par, you swap over. But really, that's not great because you have to kind of stop and start. I'd say the first option is probably the best way to go, but there is a lot of pitfalls. I mean, at the end of the day, you're moving not only from a different framework to a different other framework, you're also changing languages. So there's no way you can even really reuse code. So unfortunately, largely it's either a big bang or it's kind of that incremental change with back and forthing between two different apps at the same time.
Okay, so lastly, how is the future of Blazor looking like going forward? What can we expect from this framework?
Hopefully big things. I think what we're seeing already is Microsoft are putting enormous amounts of resource into this framework. What started off as an experiment about 2.5, 3 years ago is now a full production ready framework. We're already seeing, like I talked about at the start of the presentation, we're seeing these experiments, it running it on the desktop, it running it as native mobile. We know that they're going to probably offer Blazor as a programming model for the new MAUI UI framework. And when that happens, Blazor will be a framework you can learn once and you'll be able to create a web application UI using it, a desktop application UI using it, a native iOS or Android interface using it, a Mac OS interface using it, a Linux OS interface using it. It genuinely will be a tool and a skill set you can learn once and apply to lots and lots of different UIs. And I think that's a really exciting prospect because we all want to be more productive, and having to constantly swap around between different UI frameworks, different languages, different ways of working is really tricky. Whereas Blazor is looking like it could offer us a programming model we can learn once and use anywhere. And I think that is a very bright future indeed.
Okay, Chris, so that's pretty much it. On behalf of everyone, I want to thank you so much for that insightful session. So yeah, thank you, Chris.
Thank you very much for having me. And yeah, I hope you've all enjoyed the talk and yeah, enjoy the rest of the conference.